This video is on the objective use double angle formulas to simplify trigonometric expressions. This is the second video on this, so hopefully you've seen the first one as well. And let's just get right into the problem. All right. So again, if you're unfamiliar with the topic, want to see more about it, please click on More Instruction. Look at their videos, their examples, their notes. Hopefully they help you out. So here we're asked to considering only the values of theta, for which secant squared theta times the cosine of 2 theta, so you're seeing the double angle here, only values of theta that make this defined and these defined, what is this equivalent to? Which of these four options would be equivalent to this for all values of theta for which these are defined? All right. So again, notice in my options here, none of these have a double angle. Right? They're all sine theta, tangent theta, cosecant theta, cotangent theta. So I want to get rid of the double angle. So before I go into the actual problem, let me refresh your memory as to what the double angle formulas are. And these were written in an earlier video. And if you recall too, the double angle formulas just came from the sum formulas, where the two angles that you were adding were the same. Right. So the sine of a double angle, right, the sine of 2 theta, is 2 times the sine of theta times the cosine of theta. This is the one we'll use in this problem, the cosine of a double angle. And there are 3 equivalent versions of the cosine of a double angle. One is this, the cosine of 2 theta is the cosine squared of theta minus the sine squared of theta. And if you replace cosine squared with 1 minus sine squared, you'd get cosine 2 theta equals 1 minus 2 sine squared thetas. And if you replace sine squared theta up here with the quantity 1 minus cosine squared theta and then distribute the negative, you're getting this one. The cosine of 2 theta equals 2 cosine squared theta minus 1. And then there was the tangent. The tangent of 2 theta was 2 tangent theta in the numerator divided by 1 minus tangent squared theta in the denominator. And you saw me use this one in the first video on this objective. But we're going to be using the cosine one. Now again, you can choose either of these 3. All 3 of these are equivalent. They're all equivalent to the cosine of double an angle, the cosine of some 2 theta. All right, so let me write out the expression they gave us. We have the secant of theta, squared, multiplied by the cosine of a double angle, right, of 2 theta. And like I said, none of the options have a double angle. So I'm going to replace this. Now, you can, like I said, you can replace this expression, this cosine of 2 theta, with any of those 3 that I showed you. And I'll show you all of them. All right. So 1. What if I did this? All right. So we have secant squared theta times, and then I'll replace the cosine of 2 theta with that first expression, the cosine squared theta minus sine squared theta. Right, now there's no more double angle. All right, and then I'll distribute the secant squared. Now, hopefully you remember that secant and cosine are reciprocals. Remember, if I take the secant of theta and multiply it by the cosine of the same angle theta, that's just going to be 1, right, because they're reciprocals. So secant squared of theta times cosine squared of the same angle theta, that's going to be 1. Minus, and then when I do secant squared times sine squared, that's the same thing as sine squared over cosine squared. All right, because secant squared is 1 over cosine squared. So I have sine squared in the numerator, cosine squared in the denominator. That's tangent squared. So 1 minus tangent squared theta. Okay. Now, let's see if that's any of my options. It's not. But I can get it to be one of these. I kind of see it right now. Remember, there was a Pythagorean identity involving secant squared and tangent squared, and I'm seeing this third option with secant squared here. Let me show you how I can get it to look like that. Recall that, remember 1 plus tangent squared? Remember that was equal to secant squared? This is one of those Pythagorean identities. So that means that tangent squared is secant squared minus 1. So I can replace this. All right, so we have 1 minus, and then I'm replacing the tangent squared theta with secant squared minus 1. And then distributing this negative. And do you see how we're going to get 2 minus secant squared theta? And this is actually one of the options that we were given. Because I'd have minus secant squared and then plus 1, and 1 plus 1 is 2. And this is one of the options that we're given, this third option here. So this expression will always be equal to this expression that we were given. Again, as long as you're plugging in values of theta for which things are defined. Alright, so that was one way to go about it. But again, I'll show you all three. I'll show you how to get to this using all three versions of the cosine of a double angle. Alright, so starting over, this is an or. I could have done this. Said this is equal to secant squared theta. And then the cosine of 2 theta, instead of cosine squared minus sine squared of theta, remember if I replace cosine squared with 1 minus sine squared, that'd be 1 minus 2 sine squared theta. Alright, this was an equivalent expression. Alright, then, distributing the secant squared again, I'd get, secant squared times 1, so just secant squared, minus, and I showed you earlier that when I do sine squared times secant squared, that's tangent squared. Alright, so I'm going to jump to that right now. So when I take secant squared times 2 sine squared, that's going to be 2 tangent squared. Right. And again, if I just replace tangent squared, with secant squared minus 1, I'll get this same thing back, you'll see. Right. So I'm going to replace this tangent squared with secant squared minus 1. So we have secant squared theta here, minus 2 times, and then tangent squared theta is equivalent to secant squared theta minus 1. And then we'll be distributing this negative 2 here. And you see I've got negative 2 times negative 1. That'll be the positive 2. And then you have secant squared theta here, minus 2 secant squared theta. So, one of them minus 2 of them is minus 1 of them. So I get minus 1 times secant squared theta. And it's exactly the same thing I ended up with earlier. All right. So that was using that second version of the cosine of 2 theta. But remember, there are 3 of them. Now, again, you don't have to do all 3. Right? What I'm doing here is showing you all 3 options. This is an or statement here. You don't have to do all 3. Just do one of them. Or, and then here's the third version, which I think will be the quickest. You'll see in a second. We have secant squared theta times, and then I'm going to replace cosine of 2 theta with that third version, which was 2 cosine squared theta minus 1. That was the third version of cosine of 2 theta. Alright, and then distribute the secant squared again. And look, remember I did this earlier. Secant squared theta times cosine squared theta would be 1, because they're reciprocals. So this is just 2 in the first term, minus, and then secant squared theta times 1 is secant squared theta, and look, that's exactly what I got in the previous 2 options. So all 3 versions can lead me to the same result. that 2 minus secant squared theta. But again, just pick one, right? Just pick one and go with it. Or if you pick one and you're working with it and it's not working out for you, you're not getting one of the options, try another version. But this is only for cosine of 2 theta though, right? Cosine of 2 theta, a double angle has the 3 different versions you can use. The sine of 2 theta has one version. The tangent of 2 theta has that one version. All right, so just be careful. All right, and hopefully watching me do this a few different ways or looking at more instruction and stuff like that, hopefully all this helps you when you're working on this kind of thing on your own. And thank you for watching.